Alright, so starting with this video, we're starting chapter 6. So we're kind of changing gears yet again. And we're going to talk about composition of functions. So this is the notation here. We've got f of g of x, which is the same as this, f of g of x. So we've seen g of x before. We've seen f of x before. Now we're putting them together. So this is a function inside of another function. So we've got f of g of x. Both of these are read as f of g of x. So the idea here is that we're starting with some value, x. We're applying a function to it. So the first thing that we apply to it is g. And we end up at a number. And then we take that number and we apply f to it. And we end up at a different number. Okay? So we take x, we apply g to it, we apply f to it. And you see this sometimes in real life. So let's say you're trying to get your salary for the year at your job. So you start with x is the amount that you get paid, and you multiply that by the number of hours in a week. Okay, so this is your pay rate per hour. Okay, you multiply by the number of hours in a week, and then you multiply by 52, and that would equal your annual salary, for example. Okay, so just a simple example to show you that this kind of thing happens a lot. Okay, we do one thing to a number, and then we do another thing to a number, and that idea is the composition of functions. All right, so let's get rid of that, and let's see how this actually works. All right, so let's say that we have f of x is x plus 3, and let's say that we have g of x is x squared plus 1. All right, and we want to figure out f of g of x. F of g of x. Okay, well, we know what g of x is. All right, this right here you can see is g of x. And g of x is this. Okay, so g of x is the same as x squared plus 1. So what we could do is we could write that in. X squared plus 1. G of x is the same as x squared plus 1. Now this we've seen before. We saw this way back when we introduced function notation. This means whatever's inside the parentheses is going to replace x. So x becomes x squared plus 1. So right here, x becomes x squared plus 1. It's a substitution, not multiplication. So x becomes x squared plus 1. So we get x squared plus 1 here, plus 3. Okay, so x becomes x squared plus 1. All right, and that's our composition of functions. And we can tidy that up a little bit and say that's the same as x squared plus 4. Okay, so that's f of g of x. Now we could do g of f of x. G of f of x. Okay, so same idea, but a little bit different here. We've got f on the inside now. So let's pick another color. We've got f of x. And we know that f of x is the same as x plus 3. Okay, so we can replace f of x with x plus 3. So now x is going to become x plus 3. We're going to plug this into g. So right here, x is going to become, let me get that red out of there so that we're not confused. Okay, so right here, x is going to become x plus 3. Okay, so we plug that in, x becomes x plus 3, so we get x plus 3 squared plus 1. Okay, so x plus 3 squared plus 1. And then we just want to neaten this up a little bit, so remember we FOIL this out. We do not distribute an exponent. So we're going to get x squared plus 6x plus 9 when we FOIL that out, plus 1. So we get x squared plus 6x plus 10 for our final answer. Okay, so there's f of g, and there's g of f. So those are our two answers. Now note, we're just finding the functions. We're not setting these equal to 0. We're not solving anything. We're just finding the composite function. Okay, let's try one more example. Let's say we have f of x is 2x and g of x is x plus 3. And we want to do f of g of x. Okay, so that means we're trying to find f of g of x is the same as x plus 3, so we can put that right here. So f of x plus 3. So that means that we're going to put that into f. So x plus 3 is going to go into f. So x is going to become x plus 3. We're going to get 2 times x plus 3. Don't forget those parentheses because they're important. And we are going to get 2x plus 6. Okay, so there's another example of finding f of g of x. Now, let's say we want to find a specific number. So you know that if we wanted to do, let's say f of 4, what does that mean? That means that we're going to plug 4 into f. X is going to become 4. And you'd say, okay, 2 times 4 is 8. All right, and if you wanted to find g of 4, you know that that means to plug 4 in here, and you get 4 plus 3 is 7. Okay, what if we wanted to do f of g of 4? Okay, it's not the same as f of 4, it's not the same as g of 4. This is a new number, f of g of 4. So there's two different ways that you can look at this. You can say, well, this is f of g of x, and I'm trying to find f of g of 4, so I should be able to take 4 and plug it into this function that it matches. And it turns out that you can do that. So if we plug 4 into f of g of x, okay, that's our answer right there. We could do 2 times 4 plus 6. 8 plus 6 is 14. Whoops, I left off my 1. 14. Okay, so f of g of 4 is equal to 14. So if you have the function f of g of x, then f of g of 4 is just plugging that in, just like we did with these other numbers. All right, if you haven't found that function yet, and you need to find f of g of 4, then what you can do is you can build this from the inside out. Remember we talked about how composite functions work. We're going to take 4 and we're going to plug it into g, and then we're going to take that and plug it into f. So we're going to take 4 and plug it into g, and we know that when we plug 4 into here, 4 plus 3 is 7. So g of 4 is the same as 7. Oops. Different color there. Okay, so g of 4 is the same as 7. So now we can take that result and plug it into f. So now we're plugging 7 into f. 2 times 7 is 14. So you get the same answer either way. You can either take the number and plug it into the composition if you already have it, or you can just plug it in order. 4 goes into g, and then that goes into f. You get the same answer either way. Okay, now sometimes in math it is helpful to do the opposite. So sometimes we have a very complicated function, like h of x, and we want to break it down into 2 smaller functions that we know how to deal with. So in this example, we're going to take a function h of x, and we're going to try to find 2 smaller functions so that h is the same as f of g. So what we're looking for is h to be the same as f of g, like this. So what we're looking for is f to be the outside function and g to be the inside function. You actually know how to do this already. We do this with graphing. So let's say that h of x is equal to the square root of x plus 3. Okay, the square root of x plus 3. So you know that when we're graphing, you identify this as a square root function, and then the stuff on the inside is the shift. That's the same idea for this composition of functions. The outside is the square root, and the inside is the x plus 3. Okay, so the outside is the square root. That's kind of the overall shape of the function. And then the inside is going to be your g of x. Okay, so that should be our answer. Let's check it and make sure that it works. So when we do f of g of x, we've got to get back to this original function that we were given to start with. Okay, so g of x is x plus 3. Okay, so replace g of x with x plus 3, and then we're going to take x plus 3 and put it into f. So we're going to take x plus 3 and put it into f, and we get square root of x plus 3. Sorry, you probably hear my cat in the background. He wants to go out. Okay, so when we did f of g, it did get us back to the original function, so that means this f and g are our smaller functions that we can use for composition.